Welcome back, everybody. This video is about domain and range and in the context of story problems and just identifying, classifying domain and range. Remember, domain usually refers to the x-coordinate, and we can think of domain also as input. What goes into a function? The input. What are you allowed to input? Is there any restrictions? Is there any things keeping us from doing a certain number? Range generally is the y-coordinate, and that's what you get out after plugging input into the function. What are the numbers and values you get out of a function? That's what we mean by input and output. But today's problems we're going to talk about what are the restrictions, what we call practical domain and practical range. Let's take the first one here. It says Rebecca has 30 paintings to sell. The amount of money Rebecca makes from selling X paintings is represented by the function. The function is f of x equals 25x. What's the practical domain of the function? Okay, well, we have this function here. And from a pure mathematical standpoint, we can put any number we want in there. Positives, negatives, whole numbers, zero, fractions, decimals, any number can go in. But in the context of the problem, we're only allowed certain ones. She has 30 paintings to sell. Okay, so she could sell 0, or she could sell all the way up to 30. Now, think about paintings. You can't sell half of a painting or a fourth of a painting. So this is how we're going to describe the practical domain. All integers from 0 to 30 inclusive. Okay, so what we're saying here, integers, positive and negative whole numbers, but we're only going to give a limit on it from 0 to 30, and we're inclusive, meaning we do include 0 to 30 instead of acting them like a boundary, where they're saying, you might have heard the phrase between 0 and 30 and marking off a range, but saying 0 to 30 inclusive means you could include 0 as a possibility and 30 as a possibility. So that's how we describe the practical domain of the function. Let's look at another one here. Elena works at least 4 hours, but no more than 8 hours. The amount of money Elena earns for working t hours, represented by the function p of t, 9.5t. What's the practical domain? Well, let's look at this function for a minute. Instead of f of x, x and y, we're using t and p. And 9.5t says apparently she's getting $9.50 an hour that she works. The practical domain, based on that first sentence, at least 4, but no more than 8. All right, and you think about hours and how we can describe hours. It's possible to have half of an hour, a fourth of an hour, hour and 10 minutes. So here's how we're going to say it. All real numbers, allowing for decimals and fractions, from 4 to 8, and there's that word inclusive again, meaning we do include the number 4, we do include the number 8. It could be part of the solution set. All right. Look at another one here for domain, a little bit more complicated. Andre has 45 sheets of paper and needs to buy more. The store has 5 reams of paper, and each ream contains 500 sheets of paper. The number of sheets of paper Andre has after purchasing X reams is represented by the function f of x equals 500x plus 45. What's the practical domain? All right, let's just look at the function for a minute before we answer that. 500x, x is the number of reams of paper, and we're going to assume you can't have half of a ream or a fourth of a ream or a fifth of a ream. But this is saying how much paper he has. He has 45 sheets. He needs to buy X number of reams, each ream being 500. The phrase up there, buy more, says, okay, we need more, so we definitely can't use 0. We need more, so it has to be at least 1 ream. But the store only has 5. So kind of that interval that we can use is from 1 to 5. And also, since we can't have half of a ream, we're going to say all integers from 1 to 5, and we're going to be inclusive again, meaning 1 to 5 could be included in that set. Now let's switch gears and talk about range. Range is what you get after plugging in the domain into the function. So in this problem, Greta has 40 raffle tickets to sell. She's required to sell at least 15. She sells the raffle tickets for $10 each. The amount of money Greta makes from selling X raffle tickets is represented by the function f of x equals 10x. What's the practical range? So we're focusing on range this time. Let's have a look at our function here. 10x, this should make sense. she's selling them for $10 a piece. X is the number of raffle tickets. Let's focus on domain first. Domain, what is she allowed to plug in? Well, it says she has to sell at least 15, but she only has 40 to sell. So she's going 15 to 40. All right, has to be whole numbers. Now focus on the range. What do you get when plugging those numbers in? 15 times 10 is 150. 40 times 10 is 400. So our effective range, let's see how we would describe that. All right, think about the numbers we would get. We're not going to say real numbers. We're not going to say integers. We're going to say all multiples of 10 from 150 to 400 inclusive. So yeah, it's a little bit more, we need a little bit more of a description there. The multiples of 10, because think about it. 15 tickets, 150. 16, 160. 17 tickets, 170. It's always going to be increments of 10 or multiples of 10. That's why we use that descriptor there for this particular range. All right, let's look at one more. Lily hikes 1 hour, but not more than 3 hours. She hikes an average of 2.2 miles per hour. The distance in t hours is multiplied by the function p of t equals 2.2. All right, where t is the time, p is the distance, 2.2. She's going 2.2 miles per hour, not that fast, but just a hiking rate. Domain, put a D for domain, 1 to 3. R for range here. Let's plug those in. 1 times 2.2 is 2.2 miles. 3 times 2.2 is 6.6. Here's how we can describe this. All real numbers from 2.2 to 6.6, and that word inclusive again. So she'll go somewhere anywhere between 2.2 and 6.6 miles, and all real numbers, meaning it's okay to have fractions and decimals in this scenario. All right, thank you for watching. I hope this clarifies domain and range in the context of story problems a little better.